Alright guys, welcome to today's class. This is Mr. Ludden and we're going to have a look at algebraic division today and how it comes up in your junior cert. So in 5 minutes time we're going to have a look at something like this and how we go about solving it. But before we do that, we're going to take a quick look back at something that you would have done in 6th class. So probably 3 years ago for all of you even. You would have done something like this. You would have been asked to find out how many times 21 goes into 6,678. And you would have done something like this. You would have said, well, 21 into 6 doesn't go because 21 is too big. So I'm going to use my two numbers here. 21 into 66. And of course 21 into 66 goes in 3 times. Now primary school you probably would have counted up, added 21s together, try to fit as many as you could into 66, but I suppose the better you get at maths, you're able to see more clearly that 21 goes into 66 3 times. So you would have put your 3 up here, and just watch the placement of your 3. Your 3 is above your second 6 there, and your placement there is important because if you think about it, your 6,678, the first 6 there represents 6,000, second 6 there represents 600, 7 there represents 70, and your 8 there represents just 8 units. So what you've told me is that 21 goes into 6,678, goes not just 3 times. Now remember, your 3 is above your 6 here, which represents your 600s. So 21 goes into 6,678. You told me it goes in 300 times. It'd be great if that was the end of your question. 21 into 6,678 goes in 300 times. But unfortunately, that's not quite the case because we haven't dealt with our 78 at the end there. So what we're going to do at this point is we're going to see exactly how many times, what is 300 times 21? So what I'm going to do is I'm going to multiply 3 by 21 here. And 3 by 21 is going to give me 6,300. So we know that 21 goes into 6,678 times. It goes in 300 times, and what I'm left with is my 6,300. However, those two things aren't the same. It hasn't gone in evenly, so we have another step or two to go. What we need to find out is what our remainder is between our 6,678 and our 6,300. So what I'm going to do is, and I'm just going to highlight this because it comes into play in our junior cert question, that's 6,300. It was a plus 6,300, but we want to get our remainder of that when we take it away from our 6,678. The key word here being take away. So what I'm going to do is I'm going to take that 6,300 away from my 6,678, and what I'm going to be left with is 378 as my remainder. So what I'm just going to stop there. What I've actually done there is I've done the first part of my question. I've said that 21 goes into like 6,600 300 times, and my remainder is 378. So at this point here, my question sort of starts again. I'm going to try and find out how many times exactly does my 21 here, does it go into my 378, my remainder, and that's going to help me fill out this part here and this part here, my tens and my units part of my question. So I'm going to start the question again nearly. I'm going to say, well, how many times does 21 go into 378? And I'm just going to take that arrow away there. I don't want to get too clogged up in my explanation. So 21 doesn't go into 3 because 3 is too small. 21 into 37 will go in 1 time. Now just watch my placement of the 1. It's going to go in right there, because what we've actually said is that 21 it's not going into just 37, because that 37 there represents 300s, 7 tens and 8 units. So the 37 there is actually 370. So at this point here, I'm going to find out, well, my 21 went into my 370 10 times, represented by this one here, but I'm going to find out exactly how many times that went in. It didn't go in the full 378. So what I'm going to do is I'm going to take this one and I'm going to multiply it by 21. And remember that one there represents 10. So when I multiply 10 by 21, I'm going to get 210. And you'll see that the 21 went into the 378, but it didn't go in the full amount. The same as when I was at the start, when I was dividing my 21 into 6,678. It didn't go in the full amount, and that's why we had to go again. So the same way as before, just down here, I'm going to see how much, I'm going to get my remainder of 378 minus 210. Now just remember that 210 was a plus. Now it's, seeing as I'm getting a remainder, it's going to be a minus. Because remainder, if I was to get the remainder of 5 and 3, to get my remainder, I'm taking away. So, and my answer of course would be 2. The same logic applies here. So when I take that away from that, I'm going to get 8, I'm going to get 6, I'm going to get 1. So I'm going to get 168. So the last thing that I have to do is figure out, well, I found out how many 21 goes into 6,678, 300s, 110, and this here now will help me find out how many units it goes in. So I asked myself, how many times is 21 going to 168? Now, at this point here, something happens that hasn't happened before, I suppose. So 21 doesn't go into 1, too small. 21 doesn't go into 16. So 21 into 168. At this point, you can count up in 21, so you can use your calculator. Probably your calculator is the best idea here. 21 ends up going into 168. It ends up going in 8 times. And we'll see now if we get a remainder from that. So that 8 I'm just after drawing here, that represents that 21 goes into 168 8 times. Let's see if there's a remainder. We're going to do our last part here. So my 8 multiplied by 21. Well, 8 ones are 8 and 8 twos are 16. So if I was to finish this off, if I was to get the remainder of those two things there, take those away, I'd end up with 0. And that's exactly what I want. If I get a 0 at the end there, I have figured out my question. I have found out that my 21 has gone into my 6,678 318 times. And just to recap, we did that by breaking it up. We did that by seeing how many times the 21 goes into the 6,000 first, then the hundreds, then the tens and the units. At the end, if you get a 0 at the end, you know that you've done this correct. So we're going to scale that up now, and we're going to take that, the ideas from that question there, we're going to take them into our next question, which is this. So you notice that I've rewritten the way that was asked of us in the question. We had this divided by this. So I've just rewritten it in the form that we're used to. In this example, we're going to go at it the same way as before, as this question right here, bit by bit. We're not going to do it all at once. But instead of looking at our placements like our thousands, our hundreds, our tens, our units, we're going to look at our x's. So actually just don't want that. This should be an x cubed. Be sure you take that down. Let me just rewrite that properly. It's a cube there. So just make sure I made a mistake there, and thank God I caught myself just in time. 3x cubed minus 2x squared minus 3x plus 2. Okay, we're good to go. Okay, to start off, we're going to look at our x's. So what we're going to do is we're going to take the highest power of x from our factor here, which is of course the x, and we're going to see how much it goes into the first thing here. We're not going to worry about the rest of it just for now. We're just going to worry about how many times is x going to 3x cubed. So to help you, if you want to put a 1 beside your x here, 1x is the exact same thing as x on its own, you can ask yourself, well, how many times does 1 go into 3? And of course your answer is 3. So that's, congratulations, that's the first part of your question. So 1 goes into 3 times. How many times does x go into x cubed? So that's your x and your x cubed. And of course x goes into x cubed, x squared times. So you found out how many times your 1x here goes into your 3x cubed. Now you want to find out exactly how much it goes in. So just like our last one, we're going to take what we found out here, my 3x squared, we're going to multiply it by everything down here. And we're going to see exactly what the story is. Now I'm going to give myself quite a bit of space here because there's quite a lot happening, or will happen down here in my question. So back to this, 3x squared times 1x will give me 3x cubed, and then 3x squared times my minus 1 here. 3x squared times minus 1 is going to give me minus 3x squared. Now we've found out that 1x goes into 3x cubed 3x squared times, and we found out that it goes in this amount here. It goes in that amount, but in the same way as our last question, we need to find out what the remainder is. So guys, just watch carefully. That 3x cubed there was a plus, so it was. But if I want to find the remainder, I'm taking that away. And if I want to find the remainder of a minus number, we're taking away a takeaway sign. So that takeaway sign is going to, I suppose, change into a plus sign for the reason that you're getting the remainder of a negative. So you're taking away a minus number. When you have two minuses coming together like that, you're going to have a plus. So just to highlight what's going on there, originally you had a plus and a minus. I know some people learn that you change the signs, but what you're getting is the remainder. So you're taking away both things. Just be careful that if you have a plus at the start, you end up with a minus. If you have a minus here, you end up with a plus here. Okay, so 3x cubed minus 3x cubed. I'm just going to put a line through those because that's going to give me 0. So 3x cubed minus 3x cubed is going to give me 0. On this side here, I've got minus 2x squared plus 3x squared. So that's going to give me 1x squared. And at this point here, you might think, well, what's the story with my 1x squared here? This right here is going to be, it's going to be like sort of the foundation block of the next part that I have to do. But you'll notice that I haven't dealt with my minus 3x here or my plus 2. So what I'm going to do is I'm going to bring those down because I have to deal with them. I have to see how many times my 1x minus 1 goes in here at some point as well. So just writing those down again, minus 3x plus 2, and my question starts again. What I need to find out is how many times my 1x minus 1 goes into my new equation here at the bottom of 1x squared minus 3x plus 2. So again, I take my, sorry, don't need that. I take my 1x and I find out, I ask myself how many times does it go into my 1x squared. Of course 1x goes into 1x squared, it's going to go in plus 1x times, and if you think about it, 1x times 1x will give me 1x squared. Now we want to find out, well, what does that mean for the rest of my equation? So with my 1x here, I'm going to multiply it by all my stuff here to see exactly how many times it went in. So 1x times 1x, so just show you where those from, 1x times my 1x over here, if you can see that, is going to give me 1x squared, and I'm going to write that down here, and 1x, so this 1x here, times my minus 1 over here, is going to give me minus 1x. Now I need to find the remainder again. You'll notice that it's the same steps happening over and over again. So I need to find out the remainder. So remember that this 1x squared here is a plus, but if I'm finding the remainder of that from 1x squared minus 3x plus 2, well, I need to change my signs, or I need to take them away, in other words. So minus, and if I'm taking away a takeaway sign, that's going to be a plus. When I do out that sum, I'm going to have 1x squared minus 1x squared. Well, that's going to give me 0, so I'm just going to put a line through those, so I know that I don't have to use them again. I have minus 3x plus 1x. That's going to give me minus 2x. And I still haven't used my plus 2 at the end, so I'm going to bring that guy down. Okay, plus 2. Now, last thing I have to do. Right now I have a remainder. I have my minus 2x plus 2. So I'm hoping that the last time that I put this thing here, that I divide this into this, I'm hoping that I get 0 as my remainder at the very end. So let's see if that works. And I'm just going to take away a few of these lines that I don't need anymore. Okay. Yeah, take that line away. Okay. So I need to find out how much this guy here goes into my minus 2x plus 2 at the end. So 1x into minus 2x is going to go in minus 2 times, and that's my minus 2 up top here. And I need to find out exactly how much that goes in. So minus 2 multiplied by this, I'm hoping that I get the same answer, like minus 2x plus 2 down at the end here. I'm hoping I get that, because then when I take them away, I'll get a remainder of 0. So let's see if that happens. Minus 2 times 1x is going to give me minus 2x, so far so good. Minus 2 times minus 1 will give me plus 2. When I want to get the remainder of that, I'm taking away a takeaway, that's going to be a plus. I'm taking away a positive, that's going to be a takeaway. When I do that, I'm going to get 0. And if you get 0 at the bottom, it's a really, really good sign. It means that your equation has gone in evenly. Or it's not your equation, your expression. Your 1x minus 1 has gone into your 3x squared minus 2x squared minus 3x plus 2. And it's gone in evenly. It's gone in 3x squared plus 1x minus 2 times. So just so we're clear, up here at the top, let me get a different colored highlighter. I'm going to highlight it in pink. In pink here is your answer. You have found out that 1x minus 1 goes into 3x squared, 3x cubed even, minus 2x squared, minus 3x plus 2. It's gone in 3x squared plus 1x minus 2 times. Just to write that out, your answer is this bit here. So 3x squared plus 1x minus 2, and you're done. Okay, guys, that came up one more time. That came up in that I can see on the exam papers, and it was 2013 question 4. So I'll do this one out fully, but I'm going to do it a small bit quicker than the one before. You can always pause the video. Actually, I would recommend you pausing the video now and trying this question, and then unpausing it and see if you get the same answer as me. So, all right. I hope you've tried the video. I'm going to start doing this now. Okay. X goes into 2x cubed, 2x squared times. I want to find out exactly how many times it goes in, so I'm going to multiply my 2x squared by all of this. 2x squared times x plus 3 is going to give me 2x cubed plus 6x squared. When I get my remainder, I'm taking away. Those two there are going to work against each other, going to give me 0, so I'm going to put a line through those. I've got x squared minus 6x squared. I'm going to get minus 5x squared. Okay, next step. I'm going to take down my minus 13x and my plus 6. So minus 13x plus 6, and my question starts again. I need to find out how many times my x plus 3 goes into my new thing down here. So I'm going to take my x, and I'm going to ask how many times does it go into my minus 5. I'll just get my highlighter down there just to make sure you know where I'm looking. I'm asking myself, how many times is my x going to my minus 5x squared? The first thing I had asked, just to loop back, how many times does it goes into my 2x cubed, and I got my answer. Now I'm asking how many times does my x here go into my minus 5x squared. Of course the answer is minus 5x. So when I want to find out exactly how much it goes in, minus 5x times x is going to give you minus 5x squared, and minus 5x times 3 is going to give you your minus 15x. Okay, finding my remainder. If I'm taking away a minus 5x squared, that's going to be a plus. That's going to be a plus. So when I find out my answer, minus 5x squared plus 5x squared, well, that's going to be 0. So I'm going to put a line through those to make sure I remember that. And I have minus 13x plus 15x, which will give me plus 2x plus 6. Last one, how many times does my x plus 3 go into my 2x plus 6 down at the bottom here? So x goes into my 2x, let's highlight that. My x here goes into my 2x plus 2 times, and let's see what the remainder looks like. Plus 2 times all of this times x plus 3. I have 2 times x, which is 2x. I have 2 times 3, which is 6. And when I get my remainder, minus, I get 0. So I have found out that x plus 3 goes into 2x cubed plus x squared minus 13x plus 6. It goes in exactly 2x squared minus 5x plus 2 times. So that right there is my answer. And I suppose just to write that out, 2x squared minus 5x plus 2. Alright. Guys, those were the 2 questions that I found explicitly asked in the exam paper questions. So asked, like, literally to tell you divide. Divide one thing by another. It could be asked, I'll just, where I have space here, I suppose just be aware, it could be asked something like, if you have let's say the area of a box is x squared plus 7x plus 10, and if you're told that the side of the box was x plus 2, and you're asked to find out, well, what's the length of the box, you know that the area is equal to the length times width. So you know that the area, x squared plus 7x plus 10, is going to be the length multiplied by the width, and now the width is x plus 2. So you know that if you're to divide both sides by x plus 2, let me get rid of the box here so I can actually write that. You know that well, L is going to be my x squared plus 7x plus 10 all over x plus 2, which is a division question, and you'd have to write it out exactly like what I have up on top here and continue on and do that question. So I suppose the point I'm trying to make here is, in your exam, they mightn't be as explicit as asking you like to divide one algebraic expression by another. They might put it in a context question, and that would usually be something with area and volume, where you're given the area, you're given the length, and you're asked to find the width. I think off the top of my head, that's I think that's the most applicable that they can give you. Just be wary of that. Guys, just to round off your key points there, and these will be at the bottom of the video as well. Those are your 5 key points. Do look back over the 2 examples that I've given you, and I'll point you to questions in the book as well to give you a bit of practice, so that if this question comes up, we can nail it in the exam. Any questions, just let me know. Alright guys, thanks very much.